So, we'll, I'll just walk over the Docker and Kubernetes plugins into the IntelliJ. So Docker is free, and Kubernetes, I think I had told you can have the Google Cloud Kubernetes plugin, so you can use that. So when you have the Docker plugin installed and you open your Docker file, for example, here this file I have opened, and when you click on this, it will run your this thing here only, and in the IntelliJ itself. And you can see here you can go to services, and you can see Docker containers. So I don't know whether service is available for community edition or not, because I have ultimate edition, but you can try it out. So under services, you will see these are two containers, and this is a container I have running. And you can right click and say stop, start, all those things, restart, pause, stop. You can do all of this. Here also it stopped, so I'm still working on this, but you can do everything, many things here. And you can exec whatever command you run, and all those things you can do. You can see images also, what all images are available. You can see networks if you have created, or whatever is there by default, some volumes which you might have created earlier. So if you click on running containers, you can see many things for that. One of the things you can see is the logs. Second thing, you can see some properties, image ID, container ID, container name. I have posted that running on my local in a Docker container. So it's showing that. Some environment variables, whatever is default, some you might have set up, it shows there. Port bindings. So I have bound the port, container port, Postgres work on 5432. So I have bound 5432 on the container to local 5432. So that when I run on my host some command on 5432, it goes to container 5432. If you have volume bindings, I think it it gave one by default, but if you have done some bindings in your in your Docker configuration, it shows here. One of the things which I like most is the files. So if you're running containers, I want to see the files, and I don't want to, I mean, you can always SSH and see all those things, but it gives you a visual representation of files inside. And that's what I like a lot. So you can see all the files these files are inside this container. So you can go and look at the files, you want to look at some configuration, etc, whatever, cron, kernel, whatever you want to do. You can browse through files here. And that's, that's pretty cool feature. So libraries, whatever folders in the, in the root, and or you can go to any subfolders and do all of those things. So this I like. So that's one thing you can do. Well, let me see if there's anything. So you can edit while running. You can right click and send edit, and you can say build image. That's another. You can build the image from here only. You don't have to run command like docker, that -t or something. We are doing image -t, so that you don't have to manually do it. You can run it from here. You can edit the configuration. So I have the Dockers running on my. So I had started the Docker machine here. Some Docker environment was running, so I have started the Docker machine here. Docker machine start, and after I started running, it started showing here. And so you can give the container name when you run the when you run a when a container, you can specify the name also. So this is about Docker and its configuration. Right now, if you see Kubernetes Explorer, it's not showing anything because I am not running the Kubernetes Explorer. I'm not running any Kubernetes cluster. So what I'm going to do now is I'm going to start Kubernetes on my local environment. So Kubernetes start. And once I do Kubernetes start, you will see, whatever images are running is trying to load that. You will see that Kubernetes coming here also. And then there are certain commands I can run from within the Kubernetes. Let's see, there is nothing. It selects your local also, but I am more interested in going here and trying to see Kubernetes Explorer. So let it load. Let it load, and then I will be able to see the Kubernetes here. Okay, while it is running, let's see where we have reached in the command. It's still loading. 71%, 75%, it's over. Let's wait for a couple of minutes. Is there anything let's check the edit configurations. Yeah, there's a Docker file configuration you can check, and Kubernetes thing. I have not played around with much, but there is something on Kubernetes also it provides. And Docker files, I have shown this already to you. You want to do something before, and these are like IntelliJ configurations. I think if you know, if you work on IntelliJ, you might know about this already. What else? So you can pull the image. So these images are on the wherever Docker repository you are connected to. So you can pull the image. For example, let's say I want to pull the image for give any image name Redis. So I want to pull the image for Redis. So it takes some time. Sorry, it takes some time to search and everything, and then it will show you these are the images available. This is pretty cool. You can always use Docker pull from your command line, but you can do from here also. And here you get an advantage. What are the Redis images available? It shows all of that, and so you can select whatever you want, and you can pull that from the repository. So that's about it. So this mini cube is starting. While it's starting, let's see. Now you see, earlier it was nothing. Now mini cube has come. It will show the nodes because it's starting, so it's still loading. So once it's run, it will show okay, one node is running. These are namespaces. We'll discuss namespaces last time. We did not complete the namespace, so we'll discuss the namespace today, and various objects of Kubernetes it shows here, and we'll go into many of these in our coming sessions. So this basically covers the about our IntelliJ setup, and it comes very handy when you are developing, and you can, instead of writing so many commands yourself, you can use the plugins available. It will increase your productivity. So let me close this because IntelliJ consumes a lot of resources. Close. Okay, done. Close. So what I'm going to do now is now let's come back to the continuation from the last session. So I will come here. So where we had left last session was on the namespaces, I think. So let's go to the namespace. Okay, annotations we had finished. So let's go to namespace. So namespace, it split objects into separate non-overlapping groups. And what are those non-overlapping groups? Those could be, different components into your company's applications, or the idea is that some components need to have more resources, some components need to have less resources. So you can define those resources using namespaces, and you can have the access control to resources by users. And as I said, you can also limit amount of resources. It's just reflection of this. If you want to get the namespace, now we'll go as per this. So if you want to get the existing namespace, you run the kubectl get ns. Ns means namespace command. So we'll do that. So kubectl get ns. So these are the namespaces you see which are already there, and there's a Kubernetes dashboard also. That's cool. We'll see the dashboard also later. Now, if you want to get the pods belonging to a namespace, then you run this command. So kubectl get pod. You can say get pod or pods and namespace, and then you give the namespace name. We'll take one. It's a kube system I want to see. These are the pods. And the kube system, right? We discuss it as scheduler, it has a API server, and it has controller manager. We discuss all of that, right? So these are the things which are coming here. Let's see what is in the kube dashboard. So there's a metric scraper, there's a dashboard. These are the 2 pods running on Kubernetes. So this is how you see the pods belonging to namespace. See, here we are seeing the pods for the namespace which are created by Kubernetes. But once you create your own namespaces, so in your organization there might be many teams using the Kubernetes cluster. You might be part of one team or more than one team and things like this. So each team's pods will also be under some namespaces. And if you know the namespace and you want to see the pods under that, and the namespace is what you or someone in your team or some other team might have created, and you want to see the pods, you could very well give that. So don't confuse because I'm giving only the Kubernetes created namespaces. You could don't confuse it with that. You can see only the Kubernetes namespace pods. It's not so. Any namespace pod you can see, or any namespace you can see, whatever has been created by Kubernetes or by you or by anyone else, provided you have access to that. Moving on. So you can create the namespace, and this is the file. So I will go into that file. We have the file, go into that. So let's, one thing we want to see is that this file uses a namespace, some namespace, and this namespace you have to create. So you can, okay, this namespace, I can either you can create via YAML file, or you can create via command line. In YAML file, you can give configurations, and this namespace you are given. That's how the name get namespace we have seen, right? Get ns. So this name will start appearing there. So what we'll do is, let's see, LT. Okay, LT is my abbreviation I have created for ls minus LTR. So I see namespace. So let's see this YAML file. Name. So the name of the namespace I have given as with -ns as a suffix, and this is a namespace name I have given. And this namespace will create, there are some containers it's supposed to create, which will be based on this image. And this is a standard, configuration which you have been using so far, right? So let's see now. So it will create the namespace, it will create pod under this namespace and set up some. We'll discuss the Liveness Probe today. We have been using it for some time, but we never discuss it. So we'll discuss it today. So now let's do one thing. Let's create this file, create this, run this file, kubectl create -f, and give this name. Oh, okay, namespace, my name. Okay, so looks like I have to create the namespace first. So I have to create this namespace. Kubectl create namespace. Let's see that file again. So let's see. This is the name. Hold on a second. Check one more thing. Here I'm saying it's a pod. So this pod uses this namespace. Yeah. So this pod uses this namespace. So I will create this namespace, and I will let this pod use this namespace. So that's what this YAML file does. So kubectl, I will use this command only, create namespace, create space, and I will do this namespace, and then kubectl get ns. Sorry, mistake. I will see this is the names I have created. Now let's do one thing. Let's try to get the pods under this namespace. So we have not created any pod yet. So let's see my namespace. There is no resource there under this namespace. Now what we are going to do is we are going to create a pod which uses this namespace, and this is the YAML file we just saw. So we run this. Now, if you see the pods, you will see the pods got created. Okay, pod got created. Now what we are going to do is we are going to see the pods under this namespace. So you see get pods, this is the name, and this is the status, and all those things. So this, you see under this get pods under this namespace. This is a pod I got under this namespace. So let's see what else is there in this. I will open that file. Okay, this is a container pod v1 main namespace containers. This is the container, and this is the image I'm using, the configuration, this is a command, and this is a name. So this is how I built the namespace and the pod inside this namespace. Hold on a second. It's running. Let's get the pods. This is the pod. Let's see, get pods. Get pods under this namespace. Yeah, this is the pod which is running under this namespace. And I will say show labels. I have not labeled it to anything, so showing label as none, and it got started some. There's a one restart 20 seconds ago. There's 81 seconds before I ran this command, almost 1.5 minutes back. Okay, now so this is the this is the namespace thing. This we discussed. This is just we ran type pod and all those things. And one thing which I wanted to show you was when you are creating the namespace, you can use. So I have this, YAML file also. Let's open that. You can. I created namespace using command, but you could always, create using YAML file. My config. Okay, let's see my namespace. No, I think I had this command and somehow had this file, somehow I renamed it or moved it elsewhere. But you could create using command. Only thing is you give the API version v1 and kind is namespace, right? So let me again try. I might still have it. No, what is my config? This is a config map. We'll come to config map later and not right now. So, I'll find it out and, discuss in the next session. Okay. Now, how we discussed that you can allocate a resource to the namespace because your cluster has nodes on the cluster have so much resources. So you want to allocate some resources to certain namespace. So this is defined here. So let me copy this. Let me copy this, and we will see there. Here, I think I had it open, resource management. Let's see this. I'll open it one more time. Here. So configure memory and CPU quotas for namespace. This is some Kubernetes documentation. So create a namespace and you create a resource quota separately. You can go through this. I will not cover as part of example, but you can go through this. You can have the hard limit. The CPU is 1, memory is 1 GB. You can limit the CPUs. It starts with 1. It can go up to maximum 2 and the 2 GB memory. And this is your resource quota. Then you are creating a pod. And then here a manifest example pod, creating a pod. This is the name of the pod, this is a container. Image is this is a resource you are allocating for the pod. And another thing which you are doing here is create the resource quota for this namespace. So you created a namespace before, quota, memory, CPU cycle. You are allocating the quota to this namespace. So, and you can see the detailed information also here. And I'm just saying, just go through this. This is a Kubernetes documentation, is quite exhaustive. If you try to create a second pod, if it has resources, it does. If it doesn't have resources, then it shows some error. So I have not gone through this myself, but please go through this. If you want to know how to assign resources, and resources are just the CPUs and the memory, 2 namespaces, and then those will be allocated to the ports inside the namespace. So that's about that. There are few commands. We will go through this and we'll revise those commands now. If you want to delete a pod, then you can delete by pod a name. So let's see. cpl get pod, and get pod and pod post returns the same thing. And this is let me check one thing. I was trying something here. So this is the replication, replica set. I will cover replica set later. I was trying it and it's running. So let me delete this first, and then we'll figure out ports also. kubectl. Okay, so there should not be any replica set. Now there should be any pod. So let's create one pod, and which will delete that pod using some commands which we are discussing now. So get, let's see, Kubernetes pods.yaml. So this is a pod we'll create now, and then delete it using by name. So kubectl create create pods.yaml. So it got created. Now I say kubectl get pods. So this is a pod which is running, and this is the name of the pod. It's ready, it's running, and all those things, right? So now let's go back, and I want to delete by name. So you can see kubectl get PO, or you can see kubectl get pods. Both mean the same thing. So now I'm going to delete this. So kubectl delete. Now you can do delete. You can run the delete command in two ways. You can say delete pods and give this name. That also will work. Or you can do this kubectl delete and say pod, singular pod, and delete this. So it got deleted. And then you say pod again, you won't find it. Right? Now, if you want to see, you can delete the namespace. Let's see the namespace first. kubectl get namespace. This is a namespace. I want to delete this namespace. So you can say kubectl delete ns and then namespace name. kubectl delete and namespace space and then this name. So it got deleted. And but it takes a while to delete it. So there's another way to delete that. We'll try that way also. So let's create this namespace again. Control C, controller, namespace, and controller. Okay, I want to create the namespace. I want to go to that command where I'm creating the namespace. Create namespace, correct? So now to delete it, we ran this command earlier. Now let's try to run this command. I never run this earlier, but let's see if this works. Namespace refresh. So you can use either of this. You can give, delete command with the namespace and then give the namespace, or you can give ns hyphen namespace. It got deleted also. So if I see the namespace, I won't find that namespace. Okay, you can delete the, ports by labels. I think I deleted all the ports, but this you can try yourself. kubectl delete ports hyphen small l and the some labels, label name and the label value. So you can use that to delete ports with those labels. So now we'll discuss the replication controller and replica set in the next, in this next session, next slide, whether today or whether now or later, we'll see. But if you're using replication controller, and we'll see what replication controller and all those things is, then you can delete the pod and delete the replication controller later, or you can delete the replication controller and it will automatically delete the pod. And we'll discuss that in detail. Now pods health. Now when you create a pod, during creation, pod is scheduled to be created on a node. Now there's a kubelet on that node which runs the pod containers, and we've seen the full flow, right? What happens when you create a pod, the flow we have seen. So basically it's a kubelet which tells the runtime, Docker runtime, for example, to pull the image, run it on the container. So kubelet is responsible. If container goes down, let's say your pod, your node is running and suddenly something happens in the container because of whatever reason, it goes down. So kubelet will automatically restart it. So now, but let's say, container is not going down, container is running, but your application is going down inside the container. And why application can go down? Because of some application, bug or some out of memory error or something. Then how do you detect it? See, if your container goes down, then kubelet will start it. But if container is up, but your application is not responding, then you need to have some way of figuring that out, that your application is not running. And that's where Liveness Probe comes into play. So we'll discuss the Liveness Probe. So let me put into slideshow. So Kubernetes can check if container is alive. I mean, basically your application inside the container is alive. So can set it for each container in the pod. Kubernetes will periodically execute it and restarts container if it fails. So there are three ways to check it. You can have an HTTP get. So get on containers IP address, port, and path we specify. So it automatically considers return code with the 200 and HTTP status codes, right? So HTTP status code with 200 and 300 are normally considered successful. But if it goes into 400, you'll see 404 or 500 internal server error or something. So anything other than HTTP status code of 200 and 300 are considered failures. There's a TCP socket probe also. You can set those also. We are not going to set this up. At exec, you can run the arbitrary commands inside the container, and maybe you have a script inside the container. The script is check the application health. And what is the application health? It can check many things. Memory, if within an application you have various endpoints, it automatically checks those endpoints, and whatever you want, it can check all of that. And you can invoke that script using exec. And once you invoke that script, and if script, the way you should design your script is, if whatever needs to whatever is, things need to run fine for your application to be up. Your database connectivity should be there. All the application should be running on this pod. Memory should be, should not be, all memory should not be consumed. Your whatever volume, should have a space and all those things. You can do all of that in your script and then invoke that script using exec. And if that script is returning 0, that means that script should return 0 if everything is fine. And if that script should return some negative value if something is wrong. So that way exe will consider the 0 as a success and negative as the, something has gone wrong. So your probe will fail in that case. So what we are going to discuss is, okay, I don't know why it's not appearing here. So pod YAML and the spec. So what we'll do is, I think we have seen that. So this Liveness Probe we have seen here only. Where is that file now? Oh, sorry, my mistake. I should have done Vim. So this is a Liveness Probe. So if your type, if your object is of type pod, and in the specs, under containers, within the containers, you can specify the Liveness Probe. This container is using this image, for example, and a Liveness Probe is you're trying to get HTTP GET on port 8080. And there is period seconds and there's a timeout second. So we'll discuss that, here. So this is what we are discussing, Liveness Probe. Okay, it came now. So period seconds and timeout second. This is what I showed you. And okay, it doesn't have that. So basically, what period second does is, see if your timeout is, it will period seconds after each 20 seconds it will keep checking, right? If any time it fails, then it will considered as a failure. And timeout is, if it checks this at 80 and at 80 never responds. At 80 is this port. It checks at this port at this path, which is a root path, and the application inside the container is not responding within 15 seconds, which is a timeout second here. Then the application is considered to be a failure, and then it will it will tell this the application is not alive. So now what we are going to do is we are going to describe the pod and we'll see the liveness there. So let's do this. So I'll indicate the pod with this pod with Liveness Probe. So what's the pod name that you can get from here? You see the name here. So you can say kubectl describe. Sorry, describe pod. So you can see anyway, it's saying Liveness Probe failed, whatever. So connection diffuse. It's unhealthy. You can see this is unhealthy for 34 seconds. And later we'll see debug why this is unhealthy, but at least you are seeing this state and it keeps saying unhealthy. Right after each 20 seconds, we said, right? Remember that this settings we said period second after each 20 seconds you check. So 24, then 20 seconds, 34, and then after 54, it will keep checking. And let's see if there's anything else. What I do is generally instead of going via this, grep -i. So this is the liveness it shows here, right? So there has been one success and 3 failures, and whatever I specified in my configuration, timeout is 15 second, period is 20 seconds, and so on. And the path and the port, it keeps checking there, correct? So somewhere you will see this liveness here. This is the liveness. You see this here. And yeah, so that's how you check this pod is live. It's not live, it's unhealthy right now. And how the liveness is set up using the liveness setting in the describe pod, which you are set up in your YAML file. That's about YAML. That's about liveness. You can do port forwarding also. So if you want, for this particular image, for this particular pod, you want your on your local, if you want 888 48 port to be redirected to this containers 8080 ports inside the container of this pod. So that's how you do that, right? So that's port forwarding. This we already discussed the liveness check. There is let's see this pod with resources. Let's check this also. Okay, let me go back here and I copy that. I think pods with resources, I think it's already open, but let me see. This is what is resource management. So you can create a pod, and this is a normal pod, and you can have the resources inside this pod. So this pod should have this memory and this CPU, and this is up to maximum. It can go up to this. There's another container inside this pod, and should have this memory and this CPU, during startup when it starts, and then it can go up to this memory and this CPU. So that's how you can assign the resources to the containers inside the pod. Correct? And you can go through this. I think this Kubernetes IE has lot many documentation. So if you understand, sometimes it confuses you if you don't know the concepts, but after you understand the concepts, it's better to go through this also. So, so that's about the resources. There are few troubleshooting things we'll walk over this, which you might encounter a lot during your development or using Kubernetes. There are many other things also. We will not be covering every error, but the major error, the main errors which you see in your when you're working with Kubernetes. The first thing is you see image pull back off. Now, what is this image pull back off? And you will see that here when you see kubectl reports. So status is here. Now let me do one thing. I will cause this problem, and I will tell you how we'll cause this. Let me delete this kubectl delete pod. I deleted this. Now let me modify this YAML file vm reports.yaml. So I am not logged into any Docker repository yet. So what I did is I added this policy, image pull policy. Image pull policy is from the Docker repository, only do when if not present. And if I don't specify this setting, then by default it always tries to go to the Docker repository and pull, because I am not logged into Docker, so you won't be able to find, and I will get this error. So let me do one thing. Let me just comment this out, come out of this, and then I will create this kubectl create. Then so now let's see the status. Okay, it's creating the container. Image pull. After some time it will say image pull back off. So let me see. So you can see kubectl logs pod. So you can see bad request container in pod waiting to start trying to fail and pull the image. It's not able to pull from the repo because I'm not logged into any repo anyway. So let's see image pull back off. After error image pull, it moves to image pull back off status. And let's go through this. It's not able to get image from the repo. Now, what could be the reason? Either you specify the image name wrong, which does not exist in the repo you are connected to, and you can see the error using. Let's run this command also. Let me go to this and run this command. You can see the real error. Okay, this is what it's saying 23 seconds before. It's a error image pullback or whatever. It's trying to pull this image. It does not exist in repository because I'm not connected to repository. So you can use this. So now how do you fix this? Let me put this in a slideshow mode. So how do you fix this? So either you can use Docker login to the repository you're connected to, or if image is existing on your only on your local and is not on the repository, then you can give this setting image pull policy if not present. Or if you think the image is in the repository and still not pulling, then there could be two problems. One problem could be that you have given the image name wrong. Check the spelling of that. Or you have given here we have given only the let me open this YAML file. Okay, VIM. So here we have given only the image name, this label also. So we have given on latest here. So sometimes you can give the version which you specify. Here given this is the version. So I have given the latest version, but you could always specify 1.0 or 2.0, whatever the version is. So you check the name of this image. If that is correct, then check the version of this image. That should be correct. There is a possibility you might have made mistake in any of those. So with this, if everything is correct, then Kubernetes should be able to pull the image. So let me now revert it back. Okay. Because it's my local, so I want to take it from local, and I will see the status of the port. It will showing image full back. So I'm going to delete this image. Delete, then port slash control V. This got deleted. Now when I run the create again, create, control C, cube, CPL, create, FN, Kubernetes FN ports, FN ports dot YAML. So it got created. Now I should see the status of this. It's running because it's able to find the image on my local this thing only, local laptop only, right? That's about the image pullback of error. You will see crash loop back of error is same status if there's no command to run. So what happens is this is a problem with the Kubernetes images. So, and you can experiment it yourself as homework, if you want. So if you pull the, let's say you pull a, CentOS image. CentOS is a version of Linux. It's pretty popular. CentOS, and CentOS is used in many production as a production server also in many setups. So you pull a, you say Docker pull image and use CentOS image. Now you run that image using Docker run command. So when you see after you pull the Docker CentOS image using Docker pull command, so you can say Docker image ls, you will see that CentOS image is there. Now you run a container using CentOS image itself. So Docker run command you say and give the CentOS image. What will happen is it will start the container and immediately it will error out. It will say crash loopback of error, something like this. Why does this happen? Once the container starts, if it doesn't have any command to run, if you don't tell it to run, it will automatically die down. So in our case, it's not dying down. Why it's not dying down? Because if you see our, our pod, we are telling, this is a command you need to run. So when container starts, it has some command to run. So it will not die down. But if I remove this command, then it will die down and it will give the crash loopback error. So, so the reason is if there's no command to run inside the container, then it gives this error after it has started up. So solution, run a command inside the container so that it keeps alive, and you can see the same thing, right? Whatever. So if it's if you are so one way is that give this command inside this. There are various other ways also to give this command inside when container is starting. You can give command to run as soon as it starts. So you can as a homework you can check this out. But to be on safer side, if you want to be completely safe, give this command option. At least something should keep running, and some if your image doesn't have any application deployed which you can run or something, then you can run some while loop, some infinite, some in bash script or something that just run this while and it just keeps running, so that at least the container will have some commands to run and it will not crash or something. So that's one ad hoc approach where during development you want to do some testing or something, and you are not able to figure out which command to run to keep the container running. You could use that, but generally you have your own commands to run some, you are spinning up container for something, right? So you are trying to do something inside, even if you're using a pre-built image, but you are using that because you want to put something inside that. So use that, use some command inside that, so that at least container will find some work to do, then it will not die down. So that's about crash loopback of error. I think this you had, this part of the assignment, a pod with multiple containers, but we'll go through this, right now also. So what we are going to do in this example is we are going to create a pod with the 2 containers, one for MySQL and second is custom Spring Boot app, which we have been using. Right now, there is there's some extra thing we'll be doing, and you will see why we are doing this. So first of all, we'll create a persistent volume first. We have not discussed persistent volume yet, but and why we need this persistent volume. When we set up, when we use MySQL container, it needs some volume where it can save the data or something. So what we are going to do is we are going to create a persistent volume. So we are going to create a YAML. So this is a YAML I have created, and it's API version v1. Kind is persistent volume claim. Some metadata I have to give, and this is a name I am giving. This is a spec. There are various storage class names. I have given standard. Volume mode is file system. Access mode is read write ones. resources is I'm giving 20 GB resources. So I create this, I run this file using kubectl create command, and I get this, it says it's created successfully. Then I can see whether it's created successfully or not by running this command, kubectl get persistent volume claim / the name which I have given, right? And you can copy paste from here also. The output of the command, you can copy paste from here also, and you can see this claim got created, and this is the volume, and this is the capacity, and access mode, read, write, or I don't know, O means override or something. So this is the access mode. Now I created a persistence volume. Now I need to create a secret. We'll discuss about secret in coming sessions. There's a big set of examples I have given for some secret object, but for timing, you understand secret. Kubernetes provide you, like it provides you pod, like it provides you namespace, like it provides you labels. It does provide you a object called secret also. So you can create the secret object, and there is various ways to create the secret object, which we will discuss when we reach the secret topic. But for time being, we'll be creating the secret. For this example, we are creating secret object from literals, which you pass it. So I'm creating a secret object, and it's a generic. And there are different type of secret objects we will discuss when we reach the secret topic. But for you understand that kubectl create secret. Right now we're creating generic type, and this is the name of the secret we are giving, and we are creating the secret from literal. Yeah, and what is the secret? We are saying password is equal to welcome123. So I create the secret, then I say kubectl get secrets. This again we'll discuss in details when we reach the secret topic. So, but for timing, when we get the secrets, I get this secret which I created, right? What was that? Password. Somewhere you should see the password also. Maybe it's not appearing. I did not copy even if it was appearing. So there will be, MySQL. Here it is. Sorry, my mistake. This is the secret we have created, MySQL password. And this you see MySQL password appearing here. And I had created, when I ran this command, immediately I run the get also. So 8 seconds before I had created. So I created the, some persistent volume claim. I created the secret. Now let's see what we're going to do. You can, there's a YAML which I created. It's called 2-pod containers pod YAML. And, I have taken example from this. I have referred to the Kubernetes tutorial on this link. So you can go and read. So this example has been taken from there. So it's a type of pod. This is the name of the pod. And here I'm using 2 containers. One is this and second is this. Now let's see, this first one is pretty simple, right? This is what we have been using so far. So this is the name of the image, latest version, image pull policy is not present. Command is this when the container starts on this command, and this is the name of the container. Now second is MySQL. So MySQL, I want to use version 8, and the name I want to give is MySQL. And again, image pull policy, if I have in my local, take it from there, otherwise take it from repository. Now, when you use the MySQL, and you can go to hub.docker.com and search for MySQL and see the documentation of that. What they want is when you are spinning up a container for MySQL, you have to pass some environment variables. So now what are those environment variables? One is you have to pass a MySQL root password. How do you pass? And this again we'll discuss a lot what is this secret and all those things when we reach the secret topic. For timing, you understand this is how you are passing the environment variable. The name of the environment variable is MySQL root password. And where it is taking the value from? It is taking the value from some reference where the secret key reference, and this key I have created MySQL. This is a secret I have created. See, you see MySQL password. So this is the name I have given here. And in this in this secret, what is the key? So this is this is the name of the secret. Within secret, I have given a key value pair, and that key name is password, and the value will be automatically taken as welcome123. So I've given I'm setting up this environment variable. I'm setting the value of this environment variable, and value is coming from some secret key reference, and that secret key reference I had created. The name of that secret is this, and within that secret I can have multiple key values. So pick up the key which whose name is password. So now this is a port. I am for this MySQL image, I'm creating a port, and this container will be listening on container port will be 3306. So container will be listening on 3306 port. This MySQL container. Volume mounts. I'm creating a volume mount. So MySQL persistent volume, this is the volume which I have created. Persistence volume, if you see, the name and all those things. Okay. So come back here. This is the name of the MySQL persistent volume. So this is a volume mount I'm doing. Before I do volume mounts, I have to describe a volumes property here. So what is the name of this property? MySQL persistent storage, and this name MySQL persistent storage should be same as the name I have given in the volume mount. So when I give volume mount name, it is going to refer to volumes having this name. Now what I'm specifying in this, I'm specifying persistence volume claim is MySQL PV claim 1, and this is what I have specified here. MySQL PV claim 1, right? So it's going to, there I have specified the storage and access and all those things, right? Now, class name, volume mode of file system and everything. So this is what I have given the claim name, and this becomes my volume, and this is the volume I have specified here, and it should be mounted on what? So I've given the path that it should be mounted on where leave MySQL K8 or something, right? This is where you mount. It's in the container, correct? Now, so I created this YAML, I run this YAML, kubectl create -f2 containers pod, then I describe this. So now, and you can see a lot of information while describe this. I think we have seen this command multiple times. Check 2 containers in a pod sharing same IP. We discussed that, right? In one pod, if you have 2 containers, both will have the same IP. So when you see describe, this pod you are describing, it will show the containers, both containers, and you check the IP address of both containers. One is this IP address. This is one container, which is your custom image, and second is the MySQL, right? But both have the same IP, and you can see the container ID for our application is this, image is this, and all this command is this, whatever is given. MySQL container ID is this, image is this, image ID is this, port is this, whatever, right? And given the environment variable. So both containers using the same, same IP address. So that's about the multiple containers. I think this ends our session of the pods. This was the last slide.